The reason why we don't get flung off the Earth is because there isn't that much centrifugal force to throw us off. The difference would be at the equator where the Earth is going 1,000 miles an hour, you are going to weigh 0.5% less. So if you weigh 100 pounds, you will weigh 99.5% at the equator. You can test this. This is a fact. You will weigh 100 pounds at the North Pole. You will weigh about 0.5% less when you're at Mount Everest, when you're further away from the center of the Earth. So these are observable facts, and you can test these. You can't get around what the observation is in nature. So, is there a reason why you weigh less at the equator? It could be because the Earth is rotating and the centrifugal force is pushing you off just a little bit. So how do we get that number, that 0.5%? That should be the question that you're wanting to ask. And we do get that number from the measurements from the scale. But what I mean by that is the math part of it. And the math, we could do experiments with balls rotating or things rotating around, and we can find what how centripetal and centrifugal forces work, and how much force to expect, because we'll do a test with a certain amount of weight and a certain amount of spin. And so we can use that test and do a different size or a different weight, and then see if it's proportional linearly, or maybe it follows a different type of path. But there's always a logic to nature. So if you're going twice as fast, like in a circle, is centrifugal force going to be twice as much, or maybe exponentially different, or whatever nature is going to show. So when we do that experiment in nature, we can understand how the laws of nature works, and we can now translate that information with bigger numbers, with the size of the Earth and then the speed at the equator, and say what you would expect. And that would equal the 0.5%. That would be right there with what is in line with what we see happen on the Earth. So you can't get around the numbers. So it would be, I'm very interested to see how someone that doesn't believe that this is the truth, how they are going to spin this, or say that this is not true. So now there's also like gyroscopes and motion detectors. I think it was a Rami, a big giant motion detector, that we've measured the rotation of the Earth and the tilt of the Earth. So this is I saw a video of this guy Bob, who's a big I don't know if he is anymore, but was at some point a flat earther, and found the tilt of the Earth, the 15%, the 15 degrees per hour. So we do have solid evidence that the Earth does rotate. There is a tilt, and we do see that there's different weights at the equator. You weigh less. We do see the centrifugal force at play. It is not a lot. Think about it. Earth is going to rotate 360 degrees in a 24-hour period. That's very slow. If I were to draw a circle like this again in 24 hours, I'd have to go so slow. So Earth is going really slow, and that is why. So if Earth were to rotate twice as fast, you would be weightless. So if Earth kept at the equator, so if you were going twice as fast, and so that would be very interesting. But we are not at a rate of spin to get flung off the earth. So that is the answer and why we don't get flung off the earth. I hope you like this video. Please like or comment below any questions that you have. I am open to discussion. Thank you.